Good afternoon. Yeah, I'm Dev Shetty. In fact, I'm sitting in for Dr. Nitsi. So he had some important things to attend to. So I'm just going to give a introduction, and also Anne Langford will be there. So both of us will be coordinating this presentation today. So some of you are here, some more people might join. And I had also invited people from Lockheed Martin, Mr. Derek McGovern and Susan Dunnings. They might hop in. I've also invited the provost, chief academic officer. Also, he might drop in and drop out. So everybody is busy with so many simultaneous meetings. So that's why it is difficult to host it. But just to say a couple of minutes, 1 minute about this Lockheed Martin. As you all know, Lockheed Martin Corporation is a biggest employer here in Northern Virginia, actually involved in aerospace systems, defense systems, military applications. It is very big, huge, multi-billion, maybe 120 billion or so. I think it may be more than that, is company. And they actually recruit a lot of engineers. Number of our past graduates have also are working in various locations in Lockheed Martin. I remember last year, one of our graduates, mechanical engineering graduate, joined Lockheed Martin and went to Florida, Palm Beach unit. So there are, at least in the last count, we heard about 30 or 40 engineers working in this area. Derek McGowan is going to give me a list of our all, uh, what's going on, and then with Lockheed Martin and who our participants or who our graduates are. So one thing about Lockheed Martin is they are biggest supporters of STEM education, not only for UDC but whole country. And they also give us support for this kind of activities. So Lockheed Martin Fellowship was set up that way. It comes from their support, where the faculty member and a student work together. They identify a topic and work on that throughout the year, make a presentation. So this presentation, which you are doing now, will be reported to them. We'll send the slides and make a small comments, which helps them to really look at the opportunities. I know some of our graduating seniors who are here have already got jobs. But then if any of you are looking for jobs, I think that is one company to consider, Lockheed Martin. It's a good company, nothing can go wrong. So with this introduction, let us start with the first presentation. The presentation is distributed into different areas: computer science, civil engineering, electrical engineering, mechanical engineering. So we have candidates from all the departments. And the students are spread between the first, second year and the final year, I believe. So the first one is from Abdusalam Bashire. Uh, he worked with Mr. Bashir worked on the topic of homomorphic encryption algorithm for an efficient e-voting system. Yeah, something which is of interest to a lot of people now, e-voting, because it is really thinking.
Actually,
Yeah.
I did cloud cryptography in a few cloud cryptography.
Okay, that is the type.
Yeah,
Yeah, that's fine. You can start now. So, Mr. Bashir is from computer science background. The faculty advisor was Dr. Timothy Oladunni. Okay. So go on, Mr. Bashir.
I can share my screen and to open the PowerPoint. Right?
Yeah.
Okay, yeah,
Do you see?
yeah, I see.
Yeah. Keep talking and ask me to change the slides when you want.
Okay,
Yeah.
this slide is fine. I'm gonna the my project title is called Cloud Cryptography Theory, Practice, and Future Research Direction. Um, in this project, I just gonna start is what is cloud cryptography, what is homomorphic encryption. Also, I'm gonna go through two types of homomorphic encryption, and then I can go through look at up homomorphic encryption schemes and properties and implementation of the three algorithms, Pyler, RSA, and El Gamel algorithm. Then I can go through comparison of encryption and decryption time between these three algorithms. Finally, the conclusion. Next slide. What is a cloud cryptography? I researched different books and different online resources. I came up with this definition. In the way, web cryptography utilizes encryption method to protect data that is being accessed or processed in the system. Or it helps users to access public cloud resource easily and safely. What is homomorphic encryption? Homomorphic encryption is is homomorphic encryption is a method which enables data remains encrypted while being processed or manipulated. It helps you and the third parties, which is a cloud service provider, to add a function to encrypt data without need to be data revealed. It can be used, it can be strangely or unusually enough activities to encrypt cloud data. Next slide. Two types of homomorphic encryption: hybrid homomorphic encryption and a partial homomorphic encryption. At the end, my research focuses on only partial homomorphic encryption. What is hybrid homomorphic encryption? Hybrid homomorphic encryption creates very fast data secure, even data is in a way in the cloud. This form is very interesting, secure, outstanding, fixing problem in on encryption. For example, to do like to find the DNA sequence, and also they do the data analysis in the cloud. When you do data analysis in the cloud, this homomorphic hybrid homomorphic encryption helps us. Partial homomorphic encryption used for crypto system allow us to homomorphically evaluate any logical evaluation without description. The sound of resulting ciphertext grows during the time of homomorphic evaluation, slightly addition or multiplication. Next slide. Here is this table is homomorphic encryption schemes and their properties. I select three researchers. In 1978, Reverest making research on RSA algorithms. The property he selected is multiplication, and the flavor is partial homomorphic. In 1985, Tahir is doing the research on Ilgamel algorithms. He select multiplicative. The homomorphic type is partial. In 1999, Pyler he make himself like a Pyler algorithm. The property he selected is additive and homomorphic, partial homomorphic encryption. I implement the three algorithms. My research is focused on these three algorithms: Pyler algorithm, RSA, and Ilgamel algorithm. There's the implementation and the protocol of how this Pyler algorithm works in the cloud. The key generation, encryption, and decryption. Then finally the plain text. This is the simple chart showing client, server, and admin users relationship in the cloud. This is like the protocol for the Pyler algorithm. This is the implementation and protocol of RSA algorithms. RSA algorithm, you're just gonna pick large prime numbers to calculate, and then you're gonna calculate pi, and then you're gonna go find encrypt the data. We have a public key as well as a private key. The RSA algorithm uses two keys, our public key and private key. Alice, this is Bob and Alice scenario. Bob sending some message, encrypted message with Alice using her Bob's public key and to decrypt and seeing the message. The implementation and protocol of Ilgamel algorithms. The key generation, also picking prime number, then the calculating this encryption. You're gonna encrypt the key, and the person who receiving the message, they use private key and decrypt the message, and then they can exchange the key. They can securely communicating on the clouds. This I did. I implement this RSA Piler Elgamel to find encryption time. Which one is going faster, the encrypted? Which one is takes time, in terms of data size. So Elgamel takes encryption time is higher than RSA. RSA is higher than Pilers. There's these the three algorithms in terms of encryption time. This is in terms of decryption time between the three algorithms. Like a Piler algorithm takes 380 times of second to decrypt. The RSA takes 300 times of second to decrypt, as well as Elgamal algorithm takes 5 minutes or 5 seconds to decrypt. Finally, in this research, I explored the techniques of homomorphic encryption in virus schemes. Homomorphic encryption is one of the most important parts of my research and a relevant technique for ensuring data privacy in the cloud. I use a case to implement the three partial homomorphic encryption algorithms. The research increases my interest in cloud computing technology and in cloud security, as well as they put me in interest in going to graduate school in cybersecurity, focusing on cloud security. So the data security, data integrity, data sharing from a comprehensive standpoint. Cloud computing helps the companies, IT companies automate uh, all organization cost-effective use of resource. And finally, the comparison of encryption and decryption time between Piler, RSA, and Ilgamal algorithms. This is my research. Next slide.
I think that's it, right? Yeah.
Yeah, thank you. I just really thank you guys
Yeah.
listening, giving the time.
So, and how much time we have for question?
Um,
Do we have time for a question or two?
we do have time for maybe two questions. Two.
Yeah. So can we have any questions? And I have one. So let me ask my question first. Your initial title was like for efficient e-voting system. That's the application. So
Yes.
based on your experience and what's going on, government is looking at it. So what do you, is there any possibility that homomorphic encryption algorithm will be used for e-voting, or what is going on in that field?
Yeah, this is a good question. Thank you for asking, Dean Shere. I did that project when I was taking cryptography classes with Dr. Timothy's. So I don't want to repeat it, that project, and then I want to experiencing in different project. That's what I do it different. I did that project when I was taking cryptography classes.
Right.
So I have experience in both actually.
Ah.
E-voting system, I think I implemented this also does advanced encryption algorithm in that systems, modern encryption algorithm.
Right.
In this in cloud cryptography, I implemented the partial one, RSA, Piler, and Ilgamel algorithms.
Okay. Okay. Thank you. So, other questions from the audience, the listeners? All right. Hearing none, let us thank Mr. Bashir for a good presentation. Okay. So the next presentation is from Carla, of course, supervised by Dr. Li Wang in civil engineering ambassador program to engage high school and community college students interested in STEM. So, like